Hello, welcome to 13.1, Right Triangle Trig. So this is the first lesson in Chapter 13. Chapter 13 is going to be all about different things with trigonometry. Today our lesson is talking about SOHCAHTOA, if you remember that from GO2 and GO1, but sine, cosine, tangent. And we're also going to learn about something called cosecant, secant, and cotangent today. So our main purpose today is to use those trig ratios to solve for missing pieces of triangles. Just a quick review, and today you do want to watch the warm-up because it is assumed in this lesson that you remember how to simplify radicals. Now, I'm not assuming you do remember how to simplify radicals, so please make sure you follow along and make sure you know how to do this. And also, it is assumed that you remember how to find a missing side of a right triangle using Pythagorean theorem. I'm guessing a lot of you do remember that, but quick review anyways. When you're trying to find a missing side of a right triangle, if you know two sides, you can use the Pythagorean theorem. The hypotenuse is always the C value, and then the other two legs of the triangle, you can make them A or B, either way, doesn't matter which one you make which there, but this hypotenuse has to be C. Then I'd go ahead and plug them in. And then I would go through and solve my equation. So I've got 1 plus 36 equals c squared. 1 plus 36 equals c squared, or x squared. 37 equals c squared, and then square root it to solve. We're going to be using the exact answer for these today, unless it is a word problem. For word problems, we're going to be doing the approximate. But if I've got the square root of 37, I'd want to simplify it if I could. It actually turns out square root of 37 can't be simplified because there's no perfect squares that go into it. So let's talk about simplifying radicals. First of all, you can't have a square root on bottom. You may remember this is called rationalizing the denominator if I'm trying to get rid of the square root that's on bottom. This first time through, I'm going to show the whole long way so that you can see why what I'm doing works, and then after that there is a shortcut you can do. Alright, so watch this. In order to get rid of a square root on bottom, I will multiply by a fraction. That is the number 1. Square root of 5 divided by square root of 5 is 1. So it's just a fancy form of the number 1. If I multiply straight across, now I've got 2 square roots of 5 divided by the square root of 25. Because if I have 2 square roots multiplied together, I can multiply together the numbers. And what happens is the square root of 25 is 5. So I've gotten rid of the square root. Now, this is the same exact value as what I started with. It just looks different. Let's look at number 3. So I want to, and by the way, the shortcut for this is that you don't have to do that middle step if you understand what's going to go on there. All right, number 3. So the short way of doing this is, if you know a perfect square that divides into 50, I can rewrite the square root of 50 as the square root of 25 times the square root of 2, for example. 25 is called a perfect square because it's something that I know the whole number square root of, and so the square root of 50 reduces down to 5 square roots of 2. Now the problem is a lot of numbers that we're going to get might be kind of big. You might not know what perfect square goes into it, so there's this other method that I had taught you, you may remember, may not remember, is called upside down division. So I would take my number, I would divide by a prime number. Prime numbers, again, are numbers that have no other factors besides themselves and 1, and 1 does not count as a prime number. 50 divided by 2 is 25, and then I keep going until I'm left with a prime number. And here, a pair of them makes 1 in front. Anything that's left over goes underneath. That was how we did that way. And again, sometimes it's faster to do this way if you know what the square root is. Sometimes it's faster to do this way if you don't know what goes into it. Let's look at number 4. Now this one, let's suppose that I don't know what goes into 200. So I'm going to divide by a prime number, divide by 2, divide by 2, divide by 2, divide by 5, and I'm left with 5. Alright, so this time I've got 2, and a pair of 2s, a pair of 5s. And I'm looking for a pair because it's a square root. I multiply the stuff that both pairs in front, so 2 times 5 in front, which is 10 square roots of 2. And the alternate method would have been to realize that square root of 100 goes into square root of 200. Last but not least, look at number 5. So now I'm going to rationalize the denominator. I'm going to use the shortcut that I had before. I just want to point out to you right now, though, I'm not done with this problem because the square root of 8 can be simplified. So at this stage, I'm going to split up the square root of 8. Okay, so that is equal to 2 square roots of 2 because the square root of 4 is 2. So really I've got 3 times 2 square roots of 2 over 8, or 6 square roots of 2 over 8, or 6 and 8 reduced to 3/4. So 3 square roots of 2 over 4. Go ahead and pause if you need to, if any of that was too fast for you. But when you're ready, scroll down and I'll talk about the trig functions. All right, so again, some of this is review for you, sine, cosine, tangent, but there's some new ones here today that you may not have learned before, and they're the reciprocals of sine, cosine, tangent, and they are called cosecant, secant, and cotangent. Here are the abbreviations for them. This one is cosecant, that's secant, and that's cotangent. So just a quick review. Let's suppose I have a right triangle, and again, this only works for right triangles. Only for right triangles, only right triangles. All right, I've got my angle based off of where the angle is located, and remember that little symbol that we use is the theta symbol. It's a Greek letter theta. All right, this side here is going to be the hypotenuse side then. That one's always the hypotenuse side no matter where your angle is. But your opposite side and adjacent side will switch places depending on where the angle is. So because the angle's here, this side's considered the opposite side. This side here is considered the adjacent side. And I'm going to abbreviate opposite with OPP, adjacent with ADJ. And now, in case you're wondering, here's how I remember where opposite and adjacent go. So adjacent means right next to. So I always think of it as, okay, so one of the sides right next to my angle is going to be the hypotenuse. Whatever side is right next to my angle is the adjacent side. That means the other one is the opposite. Also, opposite could mean opposite the room from someone, so like across the room. So it's across the triangle from the angle. All right, so I have these trig functions that find values of angles for me. And if I have a sine of my angle, that is actually going to be the same value as if I took the opposite side divided by the hypotenuse side. The cosine is equal to adjacent over hypotenuse. And the tangent was equal to opposite over adjacent. Remember from GO1 and GO2 you learned SOHCAHTOA was the way you could have that memorized, because those are the ones that you'll have to have memorized for ACT, MCA. Cosecant, secant, and cotangent aren't on the ACT or MCA, and here's what's happening with these. Cosecant is actually just the reciprocal of sine. So I literally mean, remember reciprocal means you flip the fraction. So cosecant is actually hypotenuse over opposite. And by the way, also, to get cosecant, I could just do 1 divided by sine of theta, and I would get my cosecant also. And we will use this because our calculators don't have cosecant or secant or cotangent buttons, so we'll do 1 divided by to get it. All right, anyways, secant is hypotenuse over adjacent, or 1 divided by cosine of theta. And cotangent is adjacent over opposite. And again, all I did was flip the tangent fractions. So if you have these memorized, you have these memorized because all you do is flip them. You just got to remember which one matches with what. And this one is also 1 divided by tangent of theta. All right, so let's just talk a little bit about finding the reciprocal values using what I just showed you. So if I know, let's say for example, I know that sine of theta is 5/7. What is cosecant of theta? Well, remember I said cosecant is just the reciprocal. So if I know sine is 5/7, cosecant is 7/5. That's what I mean by reciprocal. You just flip it. Now, if cotangent equals 2.56, what is tangent of theta? Now, here's something that I didn't yet mention. Cotangent is 1 divided by tangent. Tangent is also equal to 1 divided by cotangent. So it goes both ways. To get tangent, I can do 1 divided by cotangent. So actually, in order to get what tangent of theta is, cotangent is this. So in my calculator, I'll type in 1 divided by 2.56, and I end up with 0.390625. Last but not least, if I know, let's say I know secant is 64 over 25ths, cosine is the reciprocal of secant, so that would be 25/64ths for cosine. Again, when you're ready, scroll down. We're going to be looking at example 2 next. All right, so when they ask us to find the 6 trig functions, right now they want us to find the fractions. We are going to find the fractions that make the ratios just using our opposite hypotenuse, adjacent hypotenuse little fraction formulas. Now the thing is though, I don't know what this missing side is. So here's where the Pythagorean theorem is. I need to find the missing side, and I'm going to use a squared plus b squared equals c squared. Remember, hypotenuse is always c. So this one I can put 3 squared plus 4 squared equals c squared. And I end up with 9 plus 16, which is really convenient because it ends up being a whole number when I square root. So square root of 25 is 5. So c equals 5. All right, so then when what I need to do next is figure out which side is opposite, adjacent, and hypotenuse. Remember, hypotenuse is always across from the right angle, so that's easy to remember. So remember, adjacent is the other leg touching my angle. That's not the hypotenuse, and opposite is across the triangle from my theta. So there's my labels. So now remember, sine is opposite over hypotenuse. So if I'm going to make my function, I'm literally just going to say 4 over 5. And then cosecant is the flip of it. All right, and then cosine is adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5. Find the reciprocal for secant, so secant is 5/3. And then tangent is opposite over adjacent, which would be 4 for opposite, 3 for adjacent. Finding the cotangent would be 3/4. Now, it does get a little bit more tricky, so please watch example B. Don't just skip ahead on this one because I want you to see what happens when I have some radicals in one of my side lengths. So here's the deal. Again, I'm going to find my missing side to start off with. Again, I made the missing side C. So this part is the same, but what happens is, for this example, I end up with 80 equals c squared, and when I square root it, that's a decimal, right? I want it in exact answer format. So I need to simplify the square root of 80 using the principles I said up in the warm-up. If you don't know exactly what goes into 80, again, I can do my little upside down division on the side. All right, and when I do my upside down division, it's a square root, so I'm looking for pairs of 2. I've got 2 different pairs of 2. So 2 times 2, and then my leftover is 5. So 4 square roots of 5. Now, this makes our life difficult because I can't have a radical on bottom. It's unsimplified. So when I try to find sine, you're going to see we're going to have a radical on bottom. Here's why. So theta this time is in this corner. Notice again, hypotenuse always stays across from the right angle. But notice adjacent and opposite are going to switch depending on where theta is. So look closely. This time theta is in this bottom right corner. So 8 is actually the adjacent side, adjacent to the angle right now. And 4 is the opposite side. Do you see what I mean? Those labels are different than over here because our theta moved. That's something that confuses students sometimes, so just take note of that. All right, now here's what I mean with the radical, or the square root. When I look at sine this time, it's opposite over hypotenuse. But when I do opposite over hypotenuse, I have a square root on a bottom. Can't have a square root on bottom, so I have to do my simplifying step. And I'm just going to tell myself right now, or tell you, I didn't give you a ton of space to write for these, so write small or use the margin somewhere. Here's what's happening. First of all, 4 divided by 4 is 1, so those cancel. So it's like 1 over square root of 5 right now. And by the way, it's to our advantage. If I know that this unsimplified is 1 over square root of 5, Let's take the reciprocal of that right away to get cosecant, because then I don't have to do more simplifying later. But this is not our final answer for sine, so I'm going to rationalize the denominator. And I end up getting 1, because remember, 4 and 4 canceled, so 1 square root of 5, which is just square root of 5, and then this on bottom turns into 5. So square root of 5 over 5 is my sine value. Let's do cosine next. So cosine is adjacent over hypotenuse. You know what, I'm even just going to write up here so I have more space. Now, that one doesn't totally cancel, but I end up with 8 divided by 4 is 2, so I've got 2 over square roots of 5. And once again, before I find my final answer for cosine, if I take that answer and take the reciprocal right away for secant, that will make my life a little faster later. So secant is square root of 5 over 2. Then, let's rationalize. I end up with 2 square roots of 5 over 5 for my cosine value. And thank goodness, once I get to tangent, it's opposite and adjacent, which is just 4 over 8, phew, which is 1/2. So that one was easy. And then take the reciprocal of 1/2, and you get 2 over 1, which is just 2 for cotangent. If you would like some practice on your own for this right now, you can pause the video and watch example C. When you unpause, I'll have the answer showing. Alright, here's the answer for part C, and I've got one thing I want you to take note of before you flip to the back side. So if you already flipped to the back, flip back to the front. I need to show you something, and that is, if I have something that has a number and a square root in it, when I square that, I have to put the whole thing in parentheses squared, and you might need to add extra parentheses to make that happen. If you look at my calculator, for example, it adds, when I do a square root, it adds a parentheses there. So I would have to do close parentheses, second close parentheses, so the whole thing's in parentheses squared in order to get the correct answer. Please watch out for that. That is a very common mistake I see students make, is that they don't know how to correctly figure that out. And then just notice that sine and cosine were the same this time. So once I had found cosecant, I knew that secant was going to be the same as cosecant. Alright, moving on to the back. I want to show you how to evaluate these with your calculator, because our calculator does not have the cosecant, secant, and cotangent buttons. Now, before I even start, I need to check my calculator mode. You may not have known this, but there's actually 2 different units of measurements for angles. It's kind of like how, you know how a distance could be measured in feet or miles, or it could be measured in meters and kilometers. So there's 2 different measurement systems. There's 2 different measurement systems used for angles, and they're called degrees. And the other unit of measurement is called radians. And we're going to learn more about that in 13 But because we're right now in degrees, and I know I'm in degrees because it has a little degree symbol, I need to make sure my calculator is in degree mode. So here's what you need to do, everybody. To do these problems, please press the mode button. Get out your calculator, pause to get it out if needed, hit the mode button. It's right next to the second key. The third selection down, you need to have degree highlighted in order to get the correct answer for these. So please go find the third selection down under the mode button. Make sure degree is highlighted. Then you can exit out of that. And so let's type them all up. So sine, cosine, and tangent are easy because I have those buttons on my calculator. So sine is right here above the second column of numbers. And I just type it all up and I get my answer. So sine is, and we're going to do these to 3 decimal places, so 0.469 for sine of 28. And again, these are the ones where it's just cosine and tangent. These are easy. Just type it up. There I go. 0.191 if I round that. Notice that you do need to round correctly to get full credit. So be careful with your rounding. And last but not least, tangent of 160 for the easy ones. And I get negative 0.364. Now, here's where it gets more difficult. Our calculator does not have a cosecant, secant, or cotangent button. You might see on your calculator these little sine, -1. That's for something else. We're going to learn about that in section 13.4. In order to get cosecant of 28, I need to actually type into my calculator 1 divided by sine of 28, because cosecant and sine are the ones that match. Secant matches with cosine, so in order to get this one, I have to type in 1 divided by cosine of 79 for E. Alright, so let's find D. 1 divided by sine of 28. So the cosecant of 28 is 2.130. And to find the secant, 1 divided by cosine of 79 is 5.241 when I round it. And then to find cotangent, again, I got to do 1 divided by tangent of 160 because my calculator does not have a cotangent button. 1 divided by tangent of 160. So I get negative 2.747. Alright, the last thing we're going to do on our video today is talk about something called solving a triangle. So now I'm going to actually use my sine, cosine, and tangent to find missing sides of a triangle, and I also want to find a missing angle. So solve the triangle means find all missing sides and angles. And for the problems we're going to see today, finding the missing angle is always the easy part because I know that the 3 angles in a triangle add up to 180. And by the way, just to make this a little bit easier, I'm going to label my triangle ABC. Why don't you go ahead and do that? ABC. So now I can specifically say I'm going to find angle A. So remember, 3 angles in a triangle add to 180. So let's just subtract off 90 and 24. And so angle A is equal to 66 degrees. Make sure that you label it with the degree sign. Now, in order to find my missing sides, we're going to use some trig ratios. So whenever I need to do that, first thing I do is label where my theta or my angle is going to be. And let's use the one that we were given originally. So I'm going to say that my angle, my theta, is right here at 24. Based off of that, that means that then y is hypotenuse, 8 is adjacent, the adjacent side, and x is the opposite side. And I can't solve for x and y at the same time. I need to do one at a time. So let's suppose that I decide I'm going to solve for x first. Whichever side you're trying to solve for, use that side and use the side you're given. So what I'm going to do is I'm going to use the opposite side and the adjacent side. So what I would do next is think to myself, okay, I'm using opposite and adjacent. Go back to the front if you need to. What trig ratio uses opposite and adjacent? So I go back to my front of my notes if needed. I look it up. Oh, opposite and adjacent, that is tangent. So the formula is this. But now my angle is 24. The opposite side is x, and the adjacent side is 8. And then I'm going to solve it. And now I just want to comment that sometimes your x is going to be, your variable is going to be on bottom of the fraction. So I actually recommend that every single time you think about it as a fraction on each side and you think about cross multiplying. So for this cross this way, I've got 1 times x, which is just x. For this cross this way, I've got tangent of 24 times 8. And now I want to tell you something as we type this into our calculator. Watch out, because you have to close parentheses your tangent before multiplying by 8. Because I only want the 24 with a tangent. The 8 is like something separate that happens afterwards. So I get 3.5618, and we'll round to 1 decimal place for these problems. So 3.6 is my value for x. Now, in order to find the other missing side, still use the one that you were given because that's an exact number. Our x is a rounded number. So if I use that to find my third side, I'm going to be a little bit off. So I want to use my exact number I was given to start off with, and now I'm going to use that with y in order to find y. So I had one little formula to find x. I've got another little formula to find y. And now when I highlight that, I see that it's adjacent in hypotenuse, which is cosine. So cosine of my angle equals adjacent, which is 8, over hypotenuse, which is y. And this is the main reason why I recommend you cross multiply, and that is, if you look at this, I've got the variable on bottom of the fraction. See the difference? Here it's on bottom of the fraction, here it's on top of the fraction. That means our solving process is going to have one extra step. When I cross multiply this time, I get 1 times 8, which is 8. And then I got cosine of 24 times y. So I'm not just solving for y right away, I've got a number times y. Cosine of 24 is actually the number 0.91 something something something. So I've got that times y, and now to get rid of a number times our variable, you divide it off. So in order to get rid of that, I just need to divide both sides of cosine of 24. Which is not bad, because that means this is what I type into my calculator to get my answer. So 8 divided by cosine of 24 to get my answer this time, and I end up with 8.8. Okay, if you feel like you want some extra practice, go ahead and pause the video and try example B, and when you unpause, I'll have the answer showing. And the rest of the lesson with angles of elevation and angle of depression we're going to do in class. Thanks for listening. Alright, so here's the answers for example B. Hopefully you did well. Make note of any questions you have or things you think you maybe want to ask me about in class tomorrow. And thanks for listening. Talk to you soon.